In this video, we're going to look at a more complicated looking substitution integral, but as we go through the process, you'll see that it really isn't any messier than any other examples we've seen so far. The key observation is that this x to the 4 minus 3 is essentially inside the exponential, and multiplying outside is x cubed, which is almost the same as the derivative of x to the 4, and has the right power of x. So that points us to a substitution where we pick w to be x to the 4 minus 3, the inside, because we know by now that when we pick that as our substitution, we're going to end up dividing by the derivative of this, which is 4x cubed. And if we get to divide by 4x cubed, we'll get rid of this x cubed out front. So that's our subtext, that's our goal. Fortunately, we don't actually need to do that explicitly. We just follow the process of the substitution steps. Once we've picked our w, we turn the crank, we find the derivative, which is 4x cubed. And then we isolate dx. Oh my God. Then we isolate dx. Well, that means bring the dx up and the 4x cubed down. So there's our 1 over 4x cubed, the dividing by that derivative that we promised. That equals dx. Then we rewrite our original integral using our w's and dw's. The integral of x cubed e to the x to the 4 minus 3 is going to equal. We didn't come up with anything for the x cubed. We leave it as is. We did call the inside of the exponential w. That x to the 4 minus 3 is the entirety of that inside. And then the dx, that is the other thing that we created an equivalency for. The dx can be replaced by 1 over 4x cubed dw. Perfect. We can cancel our x cubeds, and we end up with 1 over 4 integral of e to the w dw. And this part we can simply integrate, but we just confirm that yes, this is simpler than what we started with, and it's w's, and it has no x's in it. We've completely removed all the x's, so there's no mix of variables. Those are both good, so now we can integrate. W is our variable. The integral of e to the anything will be the e to the same thing as long as it's just a simple expression, plus c for our integral. And last but not least, we go back to x's. Our w is equal to x to the 4 minus 3. So we have 1/4 e to the x to the 4 minus 3 plus a constant on the outside. Even though this integral looked hairy to start with, by just choosing the appropriate substitution, we transformed it very easily into a simpler integral that we could evaluate and then just work our way back to x's.